Welcome to the last session of this video. As you know, in the previous session we have completed our pipeline, and in this session we just try to cover several aspects, ideas, improvements and so on. So let's get started. First aspect to consider is the dry principle, the don't repeat yourself principle. Basically, if you check out our Jenkins file, you will notice that several parts of the code are repeated. It will be a good improvement to try to define several methods in order to eliminate this issue. Another issue is related to usage of databases and volumes. Since we are using Docker containers, we need to use volumes to avoid losing data. In advanced cases, we even need a file system. Also, is not recommended to use in-memory databases or test databases as we do for SonarQube. It is recommended to use a real database as MySQL for Sonar, also for Jenkins and so on. So each time we need to use a database, is recommended to avoid in-memory databases or databases that are dedicated for tests. This of course in production. Further, we have to talk about security. In our example, we have used the Jenkins administrator account, Artifactory administrator account and so on. In production, you need to increase security. You have to rely on Jenkins security matrix, on roles, permissions and so on. Artifactory also has a powerful security layer, so we don't have to rely on default accounts, on administration accounts and so on. So this is another important aspect. In order to improve the pipeline performance, in order to run it faster and use less resources, it is a good practice to reuse the binaries. For example, we download the binaries from Artifactory, but sometimes you may want to reuse binaries using stashing, archive and other pipeline features. So it is a good practice to reuse binaries whenever you can, and this will decrease the time needed for the pipeline to execute. Another aspect, it's about retrying connections. Sometimes when you need to connect to remote services such as repositories as GitHub, Bitbucket and so on, when you have to connect to some other services like Artifactory, the first attempt may cause an error. The service will not respond at the first attempt, and this will cause the pipeline to fail. Maybe if we implement a retry technique with a timeout, then the second attempt may succeed and the pipeline will be able to continue. So retrying connections is also a good practice. Now, as you saw in the pipeline code, we have used or we have relied on several defaults path. For example, path for reports from JUnit, from static code analysis tools and so on. In production, I think it is a good practice to use explicit paths, because default paths may vary depending on the used releases. Maybe an update of a tool that now has a different default path will cause the pipeline to fail, while if we use explicit path, we obtain more consistency. Another good practice to consider is the usage of checksum and fingerprints. By checksum, you can ensure the integrity of data, since in a pipeline we transfer files from between machines, between stages, and so on. It is a good practice to know that the data integrity is preserved, and in case of manipulating sensitive data, in order to identify, monitor, and have a protective control over sensitive data, using fingerprints is another good practice in production. Waiting for services to start is another good practice. For example, application servers, database servers, SonarQube, and so on are applications that takes time to be available. So it is a good idea to ping their ports and to be sure that the ports are available, that the applications are listening. Otherwise, the pipeline may fail because since the service we try to reach is not available yet, is in the pending state, or is about to start, then the pipeline will fail. So ensure that the service that you try to reach responds on the specific port. In order to obtain better performance and optimize the pipeline, it is a good practice to try different architectures. For example, our pipeline design is just a proof of concept. It cannot be used in production. For example, you will not use in production sonar and PMD and findbox and checkstyle together, since sonar is already executing these tools inside. The way that you defined the architecture may affect the pipeline performance. For example, you may want to run everything inside a single container and have only the performance test in a separate container. You may choose to run everything in a separate container and all containers in parallel. You can try a hybrid architecture, for example using EC2 instances and Docker containers. You can use Docker Swarm. Also you have to take into account the Docker orchestration tools such as Kubernetes, Apache Mesos, and so on. Basically tools that helps Docker to perform better. Also, you may want to consider to build the entire pipeline from source code using pipeline code. In our case, we have a hybrid implementation. Remember that we have several settings in Jenkins interface, but some of those settings can be also accomplished directly from the pipeline. For example, via the Jenkins code pipeline, we can build images, Docker images, we can start containers, we can stop containers, we can run containers, so we can connect to different Docker machines. So we can do this from source code also, but you have to take into account if this is convenient for your case, since when we add Docker code, Docker specific code in the pipeline code, then our pipeline code is dependent on Docker. Other way, we can switch from a Docker infrastructure, for example, to simple machines without a Docker, and our pipeline, if doesn't depend on Docker, doesn't contain Docker specific code, it will work out of the box, while all we have to configure is our agents. Okay, so this was the last session of this video, and I hope you have enjoyed it and you found it useful. Bye bye.